Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. For those of you new to the show, let me tell you just a little bit about what we cover on this podcast. When you think about the history of data, of course it goes back thousands of years, but kind of more current times, when IBM started building mainframes and those first big computers came out, pretty much all the people, all the applications were centered around that computer in the same building. And then you fast forward through to where we are today, where we have more powerful computers than that in our phones. We have cloud computing. Our cars are generating a massive amount of data. Data has become incredibly distributed. And what we cover in Data Unchained is talking about as data has become more distributed and the tools, the applications, and the people using that data are also distributed. What are some of the challenges organizations are running into in their data architectures and their business strategies? We talk about some of the solutions that are out there to help you, take advantage of the most modern tools to wrangle this problem, and then business outcomes that customers are getting when they tackle this problem successfully. So with that, first, let me introduce our guest today. Ben Steer is joining us from London. He is the founder and CTO of Pometry. Ben, thanks for joining.
Thank you very much for having me.
Ben, before we jump into the meat of the show, maybe tell us a little bit about your background.
Yeah, sure. So I am a Londoner through and through. I've lived here all my life. I went to study computer science at Queen Mary University in London, which is in the East End. I stayed there for a very, very long time. So I was there about 10 years. I did my undergraduate, master's, and then my PhD.
So you were a good student.
Yes, I think the thing is that
the undergrad.
I mean, it's so I met my PhD advisor in second year. Me and my now co-founder Hamza went to so he organised a internship at HPE in Bristol, who were going to fund my PhD. And we were working on some interesting problems as kind of a precursor to what then become my PhD project, and then later on what become our company. So I was there for a good while, then done some postdocing in the Alan Turing Institute, which is the kind of central hub for AI innovation inside of the UK. So almost all of the UK universities pay in quite a substantial fee to be members. And then it is kind of like a central point for UK universities and government orgs to kind of collaborate. And one of the exciting thing about them was that they have a lot of funding tracks for actually building software. So for any academic listeners or anyone that's sort of dealt with universities in general, will have experienced the problem of, if you build a tool, it's normally for some sort of novel solution. Like you've got, a problem that you want to solve. And then typically once you've written the paper, the software gets thrown in the bin. And so you end up with lots of people solving the same problems. And they had some funding available for turning, like, if you already had some software, can you turn it into something that's at least academically like production ready? So then other academics can pick it up and use things and so on. So then at the end of my sort of stint at the Turing and at Queen Mary, I got involved in Conception X, who are a startup accelerator based out of UCL and focused on turning PhD students into like entrepreneurs. So unlike in the States where, there's kind of the classic, like you'd get 2 years in, you've come up with a cool idea, drop out and get funded. A lot of people in the UK that have built cool stuff tend to just go off to, your FANG organizations or get a sort of general tech job in a bank. And through them, we were able to meet some investors, got funded for our company in sort of 2021, and have since then been building out the tool for a variety of different versions that we can get into. And
you and I first met at an event here in the US, I believe, at one of Gary Greider's events. Is that correct?
Yeah. So, we was giving a demo on some of the mixture of sort of the graph space that we typically work in and more into the vector space, which obviously with the last year or so of LLM hype has allowed us to kind of explore both aspects. But it's an amazing event with some fantastic people. I actually just got off call with another group of people that I met there. I mean, the amount of people that I met there that I've been catching up with since has been phenomenal. I can't wait for the next one.
Yeah, the brain power per square meter is pretty high at those events.
It's a very intimidating room.
It is, yes. And Gary was actually on this show just a few episodes ago, actually. So it's kind of cool to see some of those different folks in the real world coming onto the show. So before we jump into talking a little bit more maybe about what you were talking about at that event and about Pometry, can you tell us what is your product? What problem are you all looking to solve?
Yeah, sure. So we build a tool called Raftery, which, as we were talking about before then, is an unfortunate name, a temporary name which has stuck for the last 10 years. But it's a mixture of graph and history. And the reason being is we wanted to take the sort of structural information that you get in a network, so the nodes or entities in your data and the relationships they share, and merge that in with the sort of interesting corpus of time series analytics that you can do. So typically speaking, when you've got a graph tool, they work based on, the latest version of your data or a snapshot. And so we wanted to bring in this idea of like, well, if I'm looking at interactions, can I do things like, I don't know, the burstiness between individuals, or, what's the sort of general distribution that they have between interactions? Or if I'm looking through the history of my snapshots or, versions of my data, can I like slice this as fine as I like? Or can I, compare to prior versions? Or, I might have some time respecting aspect of, if I'm, say, following money through a financial network, I want to make sure that, the money that I follow is after the transaction that come in. So kind of merging in a lot of these sort of typical time or like historical questions in with the structure of a network. And there was no real tools that were doing that. And that was kind of the first sort of focus that we had. The other side of things that we build out in our tool is on kind of big data, small machine. So a lot of the tooling that you see, and obviously as you were talking about at the start, is very distributed. Well, not so much, maybe not so much anymore, but sort of microservice-y, lots and lots of different pieces flying around, and a lot of graph problems when you distribute them have this issue of like trying to partition a graph in a sensible way is a nightmare. And you end up with lots and lots of data traveling around the network. And actually, if you get, a really hyper-optimized engine on a single machine, and deal with the sort of memory constraints properly, as we'll probably get into, you can get a whole heap of good processing done locally. And this is really nice for like, especially if you've got things in where you're trying to reduce down cloud costs and so on.
So your demo or the talk you gave that I saw was really compelling, and this isn't exactly the format where you can draw and show the workflow. So right. we'll have to use our words, but it was really interesting to me, and I found at that event a lot of the people at an event hosted by Gary Grider, who's an infrastructure person from the HPC or supercomputing space at Los Alamos. There was an interesting mix of people in the room, all the way from your side of the business, where you're really kind of capturing and looking at the data sources and the data sets, and then complex infrastructure things about how you optimize processors and things like that. So let's take just a step back and talk about how do you get access to the data that you're analyzing? Where are you connecting into the whole, data infrastructure?
The biggest problem that we have when we speak to a client, there's three aspects of, do you have a question that you really care about? And then often, the answer may be yes. The second is, do you have the data, which is sometimes a yes. And then the third question obviously is, okay, how do we access it? And, as is almost always the case, that third one is really, really a sort of sticking issue. And a lot of tooling, especially in our space, tends to be like very SaaS based. It has to be in the cloud. It's all, all or nothing in our infrastructure and so on. And so we tried to go very much the other way in that. So Raftery itself operates, it's about if you have all the Python libraries, is a sort of 20 meg wheel. If you strip that down to the underlying APIs, is about a 7 meg binary. And then, so you can just sort of put that wherever you like. So one of the sort of specialty areas that we work in is you've got your data wherever, be that on-prem, in cloud, on a laptop, in an air-gapped set of machines, on Snowflake or Databricks. And then you can just deploy Raftery wherever it is that it needs to go. And so there may be some building of custom algorithms for a particular client or packaging that up in some way. But yeah, ultimately we're doing very much like move the compute to where the data is, because it removes so much of the friction that the average person with sort of, very, very restricted data or some sort of covenant that blocks them from sending it elsewhere would have.
So Ben, you guys have a concept, I think you call it big data small box. It's kind of a memorable term. Can you tell us a little bit more deeply what you mean by that and what the benefit is?
Yeah, sure. So I guess there's kind of two sides of it, which I see, which is A lot of the clients that we speak to, especially when they're doing graph workloads, they tend to be using tools which require everything to be in memory, which means that if you've got like, 4 terabytes of data on disk for a graph, you need 4 terabytes of RAM, which, if that needs to be, say, online continuously, that becomes a very expensive box to run. You're going to be talking sort of millions over the course of a year. And which is, it means that a lot of these use cases are kind of, they might be solvable, but they're not like economically viable for most organizations outside of, maybe some government orgs or a bank. So we wanted people to be able to do that sort of processing, but on much more sort of accessible infrastructure. So the sort of big data small boxes, if I have this 4 terabyte graph, why can't I run this on a machine that has 4 gig of RAM? And, and now if I've got really fast NVMEs under the hood that have super high IOPS, and now I can sort of memory map all of that data and then just page in and out the stuff that's important to me, whether that's the core graph structure, some property column, or, some aspect of history for whatever algorithm it is you're running. It might not go as fast because obviously you've got to deal with the fact that you're pulling everything in and out. But it now means that you can answer that question in an accessible amount of time without, really spending through the nose on some of that infrastructure.
I think anybody who thinks about these architectures instantly is thinking about security. Mm-hmm. Do you have to worry about like user access, who can see the data? How do you think about that? So
the current version of Raftery is basically if you have access to the machine, then you have access to that data, and therefore so it's kind of an embedded tool in the same way that it's just kind of reading maybe some underlying parquets that are on either a disk that's attached or a network disk or whatever it may be. One of the things that we're quite interested in exploring is we have a sort of multi-layer model inside of our inside of Raftery, where you have sort of you've got like a red layer, a blue layer, and a green layer. Is exploring limiting sort of particular layer, like edge access, property access, and so on. At the moment, that's not the case. We've got some clients that are interested in discussing this, but typically speaking, our approach has been okay. If it's in an air-gapped machine and it's kind of locked down to a particular set of users, and because it's fully embedded and nothing's going across the network, then if you've got that machine, then it's you're sort of happy to explore it using our tool.
Very fair. That makes sense. And then let's talk about the questions. The customer has a question about their data, or a question they want to ask. Why would they go to you versus, maybe like a private language model that they've deployed? Like, how do they decide, from your perspective, which tools to use to get information about their data, especially in this crazy world of AI that's changing every day?
Well, I guess the way that I like to think about it is there's the sort of OLTP-esque questions that people see. So there's, that whether that's network or relational based data, where I'm going to, I pick an entity, I want to look at its neighbors, I want to ask them some, like maybe some properties about their neighbors, and so you have kind of nice queries for that. What typically we find is that you have 2 or 3 money queries, as we call them, which is that like, okay, if you can solve this problem for me, I'm going to make 10x money, or I'm going to save 10x money. And like, that's kind of the actual reason that the people will buy a tool. So what we normally do is we'll come in and discuss with someone, do you have what is the burning list of problems that you have? Like, give me the top 3. And if I can solve one of them, then let's solve that as kind of soon as possible. So we typically do like a 2-week to a month POC or like period for getting people through the door on a particular problem. And if I can solve that for you, and then there's more problems, okay, well, let's kind of like go out towards those. So, I mean, there's a sort of self-serve element of our tool where you can go and try things. But typically speaking, if a client or a prospective client is speaking to us and trying to like solve a problem, our go-to is like, okay, well, let's just, before you decide whether or not you want to keep us for a year or 2, let's just go solve that hard problem for you. And if we can do that, then, surely we're going to be able to do others.
And it definitely resonated with me that there's a lot of data analytics occurring other than large language models. Large language models are popular. Data analytics is a much bigger problem, or a bigger set of questions that people are focusing on. Maybe talk just a little bit about when you use Snowflake or the different types of analytics out there that businesses are trying to solve, and some of them are simple. Maybe just a few questions that they're trying to look at.
The interesting aspect that I kind of break down is that there's tools like ours and maybe something like DuckDB, etc., where like someone's trying to solve one, like you've got a really hard question and you want to solve it, and typically speaking, or you might have several sort of distinct problems that have quite nice, like, tools that are specified for them. So you might have like I don't know, you're doing some graph neural network learning, and you're going to do that with PyG. You want to get some analytics on networks, and you're going to do that with Raftery. You've got some large-scale relational query you want to ask, and you're going to do that with DuckDB. And so my kind of view on things is if you can pick the best tool for the job and they all interact really nicely together, then you can build these kind of pipelines. I think that what the sort of Snowflakes, the Databricks, etc. of the world are trying to do by sort of give us all of your data, we'll deal with everything, we'll store everything, and we'll have this full ecosystem for you. And, they obviously they deal with a lot of the security compliance and so on, which is, I think, one of the sort of large offering that they have there. But to me, that you then get stuck in, they're sort of getting you stuck in so that, okay, well, now I have to work within your ecosystem. And, say if there's a new package that you want in Snowflake and they say, well, it's not going to be there for 3 months, then you're kind of like, well, I guess I'll wait. I understand why people do go into that space, and obviously they manage a lot of the, okay, you've got to spin up a cluster of 200 machines to, brute force your way through this SQL query over a load of parquets you have on disk. But I'm still, I guess, maybe a little bit more kept in the world of, okay, well, actually, I've got 5 different tools, and as long as I can build a nice pipeline between them, then this is, phenomenal. Everything's doing what it should do. On the LLM side, my feeling is that the data analytics and the ML world has a whole host of really great stuff, and where the LLMs come in is allowing a user to point at the right pipeline. So the stuff that I was showing off at the conference we met at was very much about, like, if I say, again, we're doing some of the finance examples. If I want to ask a question like, I want to generate a KYC report or a know your customer report over a particular company, then I can have an agentic model read that question, go off and say, okay, well, I've got 5 pipelines, one for KYC, one for anti-money laundering, one for like onboarding of customers. Okay, cool. This appears to be a KYC question. So I'm going to go into this pipeline. I'm going to go and find via a similarity search in the sort of vector view. Okay, let me go and find nodes that are similar to this. And then via the graph view, hop to their neighbors, find relevant entities. Is anyone got a suspicious activity report? Anyone flagged as an entity we can't onboard, etc. Okay, let's return these documents. And then those documents are then summarized in a lovely... So I think the sort of, in my mind, the analytics and the ML stuff is exactly the same as what it ever was. It's perhaps lost a bit of its sheen because, the new and cool thing is about, and everyone wants to experiment with it. But that seems like it's just allowing that kind of entry and exit point for your data to be much easier understood. And you don't need to be a Python expert to kick off like an ML pipeline now. But you still need those guys to kind of build a couple of pipelines under the hood.
I know you're not in the marketing world as much as I am, but there's kind of a saying in the marketing space that the thing everyone wants to talk about in the news, if it's going to take off, usually takes 5 or 10 years to really be deployed in a customer environment. And, the reality is there's a lot of talk and interest in language models, and they are valuable. But if you look at a typical enterprise 5,000 customer, they have a whole bunch of analytics tools deployed today. And they're doing some language models too, and they all are for different reasons. And so I don't want to trivialize that a bit. Deployment in the real world of what developers need and is a little bit different than what you might read in the Wall Street Journal or on the BBC,
No, but the thing is, it is really exciting. Like, I think the first time that anyone opened up ChatGPT and typed in a random question and got a decent answer back, I think had a sort of realization of, oh, okay, I don't think things are going to be the same sort of post this point, because it, like, the barrier to entry for, is zero. Like, I can give that, my mum has no idea about anything that I'm building, and I can show her that, and she understands instinctively what's going on.
Exactly.
So,
exactly.
And that's super exciting. And I think what's really cool with what we're trying to do is, if you can do that mapping between the sort of complicated and hidden patterns, like, the analytics that you define for, say, anti-money laundering are sort of very specific graph patterns, or, depending on client to client, they may have different ways of defining things. most of the people that are like investigators at a bank aren't going to understand that, but having that kind of interface where they can ask questions that gets translated into something that runs under the hood and then brings them back an answer that they get is transformative, because now everyone's able to access the sort of expert a sort of pipeline, and to be able to sort of play around with that without having 1,000 data scientists specifically like one-to-one with an investigator to be able to ask questions.
Yeah, and you did talk through that kind of case study, I think, when we were together, and just sharing for our audience who's listening to the show. It was a really interesting pattern of thinking of how do you track these complex, seemingly unrelated data sets and find where the kind of the correlation was. And if you are interested in this type of work, I definitely recommend reaching out to Ben and asking him to walk through that case study with you, because it really helps you look at different unrelated data sets that actually there was a relationship, and how this technology really helps with that. I found it super fascinating. And you can imagine that there's analogs in pretty much any industry of those types of distributed, isolated data sets, and how you can find commonality or answer questions associated. And that's really the meat of what you were talking about, I think, at Gary's event, at least.
Well, first of all, thank you very much. I would very appreciate anyone reaching out there interested in this. So one aspect of which is very interesting that we find is that a lot of data tends to be siloed. I'm sure that anyone that's worked in any industry for any period of time has run up against this problem of like, I could answer my question if these 10 different people would allow me to access their data at the same time. So obviously you have to get through the sort of security aspect of being allowed everything. But being able to have a tool where you can pull 10 different data sets in totally different formats all into one model, or to build, several different models, depending on the sort of question that people are asking is really important. But there's this kind of, this sort of idea permeates across a multitude of use cases. I mean, the reason I think graphs are cool is because when I look at a table of data, I don't inherently understand what's going on. But if I see a doodle of like, a person over here with a line drawn to them and this person over here, I instinctively know, okay, well, that person's connected to this person and this is why. And like, so it's a much more human way of thinking. And then when you apply a context over the top, whether that's finance, supply chains, project risk management, there's a whole host of different ideas. I mean, we kind of specialize in finding networks where you don't normally expect them. So we had one client, as an example of this that we're speaking to, that had a load of insurance data on boats. So these are like large tankers that are going around the ocean, and they were interested in ship-to-ship trading. So you'd have like an American ship that would leave port, it would meet a Chinese ship in the Indian Ocean, they would trade goods at sea. The Chinese ship would go to Iran and sell the goods, and then the American ship would go to like Dubai and sell the goods on paper. So actually, like, according to the ship manifest, nothing bad has happened, but actually there's this kind of like, black market trade that's going on. And you can build a network with like a geospatial network of locations and boats and see how that, like, where they co-locate at particular times, and then, feed this information live to basically say to a Coast Guard, hey, you need to go and like see what's on this boat. And so that it feels a bit sort of James Bondy, but like it's very like there's not inherently a network there. And like once you have these interesting data or interesting questions, oftentimes these things sort of pop out, and that's what I love about what we do.
I think it's really cool, and the fact that you have a perspective or a mentality in your go-to-market of let people give it a try and see what they can do with it, making it very accessible, I think is pretty cool. That I believe you're all or largely in the open source community. Like, how do people get access to your technology?
Yeah, sure. So we're the majority of our tool is open. The only closed component that we have is the on-disk capability. So there's an in-memory model. You can if you go onto your terminal and pip install Raftery, it's a one-line install. It'll then be available for you to play around with. But then you're sort of limited by the amount of RAM that you have on the box. You can still deal with, on like a laptop, tens to hundreds of millions of nodes and edges. But if you get into the I've got a terabyte of data or 20 billion edge network, sort of all transactions for 5 years inside of a bank or something like this, then we have an arrow-based on disk representation, which will run that sort of large graph on a machine that has 16 gig of RAM. So I can now do these much what I would say in other tools are almost intractable questions. either locally or on like a small instance in your cloud or in your cluster, which I think is transformative for a lot of people, because we see a lot of people that have a £10 million a year cloud bill for some of this graph processing that they're doing, and you can like reduce this down by orders of magnitude. But yeah, and obviously hop on there. We have an open Slack. You can ask us any questions you like, and then if you have a burning question, obviously just reach out to us and we can help you solve it.
So how do you usually get into an organization? What is the, I would call it sales motion, but do developers usually get started, figure out this is a cool tool, and then you kind of move and permeate broader in an organization? Or is there a CIO somewhere who is saying we need this kind of information?
I think it's about 50-50. So we've had, strangely enough, in the last, I'd say 6 to 8 months, we've had a massive uptick in people approaching us and saying, I have this problem. I know it's a temporal graph problem. We've tested the tool. I want to, let's go. And so and obviously, when I leave those calls, I'm like, oh my God, how do I do that again? That was amazing. And so, sort of those aside, it's either we've had people that have kind of have sort of independently come up and realized, okay, well, I need a graph structure. I need some time series. And then have tried to cobble something together, then gone, oh, this is a massive pain in the ass. I'm not working on the actual problem that I want to work on, because I'm now building a tool. So they have a Google, they find us, and then they kind of reach out. I discuss with them, and then they say, oh, I need to go and see if I've got budget, etc. And then you have this kind of bottom up. But we've had a couple of times, either through investor introductions, or now a lot of our clients, if there's not a competition aspect, will recommend us to other people that are working in a similar space. And they'll come in and say, I have this issue. My friend says that this is a great way of doing it. Can we set something up? And as I was saying earlier, ultimately our whole push is always are we solving a hard problem for you? And let's get to the meat of that straight away. Because we've had previously, you set up a trial and people are kind of poking and prodding and it doesn't really go anywhere and it kind of peters out. So yeah, very much our approach is let's find something that's really hard that you can't do. You want to solve it yesterday, and let's get that through the door. And then once we've kind of proven that out to people, most people are very happy to say, oh, well, we've got this. Here's my long list of other things that are horrendously broken. Can you help me with these as well? So yeah, I think that's kind of. As I said, I don't think I'm the best marketeer, and I don't think anyone in Pometry is. I think we're probably something that we definitely need to work on. The website's definitely something to go by that. So for anyone that Googles Pometry, please go onto the GitHub instead of the actual main website. But
be gentle. But that's the new rage, right? People want technologists leading companies. They don't want, finance people and marketing people leading companies. That's the place you want to be right now as well.
No, I hope so. I mean, I enjoy it. I think that we've built a great team that are really interested in solving hard problems, and ultimately, I guess when you put your cards on the table, if someone's paying you for something, they want you to solve a problem, not to to look cool as a partner on their website or something.
Excellent. So, if folks are looking to reach out to you all, we'll put a link to your GitHub in the show notes to make it easy to find. Anything else that you would recommend pointing folks to looking at other than not the website, or be gentle if they do?
Indeed. So probably the best. So the easiest way is to email me directly. So ben.steer at pometry.com. On the website, on the GitHub even, there's a link to our open Slack. So that's just for the Open Raftery community. You can join there and ask any questions. Obviously, raise an issue on. We've had people that have put their that put an issue on the repo and just said, "Hey, this is my email address. Can you contact me?" Which is an interesting way of reaching out. But it worked fine. That's not a problem. Emailing us, joining the Slack, and chatting, or we obviously monitor all the community on the GitHub and so on. Is the easiest way to get in touch.
And again, I just emphasize, you'd think I'm trying to have a reason to try to pitch this company. I don't. I just saw him and was really impressed. And in fact, our founder, David Flynn, who's a very difficult man to impress, was really impressed too. Seeing the idea of visualizations of complex data sets, the example of, illegal trading occurring where the Coast Guard needs to get involved, it comes together really quickly to see the power in what you are doing when you have a chance to actually show a visualization or two. So for those listeners who are thinking, I might be interested, give it a chance to have Ben show you the visualizations? Because it's pretty freaking cool, honestly.
Oh, no, thank you very much. And so one of the things that we've been working on recently is that we have an open version of our UI as well. So we basically built a base set of libraries that after you've done your analytics, you can run a Raft3 server. You can then query that via GraphQL to get like a nice block of JSON out, which you can then like build a UI on top of. And so there's an open version of whatever graphs you build in Raft3. You can just save to disk and then instantly visualize them in the open UI. So yeah, you can also play around with that. That's all available in the pip install to run the whole thing. And then so a lot of, again, on this kind of like reducing friction and the sort of user experience. I want both the data scientists and the UI engineers to all be excited about using our tool, and not for like one of them to be happy and one of them to be cursing. And it's like, so it's at every stage we do a lot of dog fooding. We build a lot of stuff on top of our tool for clients, and anytime that something's frustrating, that goes to the top of the list of like to fix, because it's like, okay, well, I'll get around that because I have no choice of using the tool, but I want everyone that's not directly in our team to be excited about like, oh, of course I'm going to pick Raft3 off the shelf because it's going to make my life 10x easier. That most engineers are not lazy is the wrong word. Efficient, I think, is probably you want to get to a solution as soon as possible. And I don't want to bring in tools that actively make my life harder. And to the point on selling in, as I'm sure you guys may have, or anyone else that's sold anything into a company, you do oftentimes have the engineer joins the call and they're clearly very happy with what they're currently using. And the idea of learning something else is absolutely abhorrent to them. So you need to convince that person that with the tiniest bit of getting over the hump of using the new tool, that everything is going to be 1,000x easier and it's well worth making the investment. Because it's you got to convince everyone.
Exactly. Well, Ben, thank you for joining the show. It's been really interesting to learn a little bit about the technology, and really this podcast wants to talk about business outcomes. What benefits are you going to get by new tech? And your final kind of wrap up there was perfect. That so much more efficient, easier for non-technical users to make sense of data. There's a lot of benefit here. So great to have you on this show, and thank you for taking the time to join us.
No, thank you again for having me. It's wonderful. And I look forward to speaking to you guys again soon.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.